In 1852, in East London, a young boy named William Henry Perkin was a bright student at the City of London School. At the age of just 14, he discovered his interest in science. He would even conduct simple experiments at home. In 1853, when Perkin was 15, he was accepted at the Royal College of Chemistry, a prestigious school where he studied under a well-known German chemist named August Wilhelm von Hofmann. Hofmann immediately recognized Perkin's potential and set him to work on his current project using aniline to produce quinine. During this time in the mid-19th century, malaria was a dreaded disease with limited treatment options, and quinine was the only known treatment. Quinine was derived from the bark of the cinchona tree, but it was expensive and difficult to obtain. August Wilhelm recognized Perkin's potential and proposed the idea of synthesizing quinine to Perkin, who eagerly took up the challenge. Working during his Easter vacation, then 18-year-old William Perkin worked in his makeshift laboratory on the top floor of his apartment on Cable Street. With only basic equipment and a limited understanding of the reaction process, Perkin used trial and error. In one experiment, he combined aniline with sulfuric acid and potassium dichromate, but instead of quinine, the reaction produced a strange black sludge. At first, Perkin considered his experiment to be a failure. But before cleaning out his test tubes, he decided to try to dissolve the muck with several solvents. To his amazement, he noticed that when he added alcohol to the murky residue, indeed it changed properties. It became a vivid purple liquid. Intrigued, he dipped a piece of silk into the liquid and found that it retained the vivid purple color, even after washing. At a time when dyes were labor-intensive to produce and often faded quickly, this discovery was revolutionary. Recognizing the potential of this vibrant, color-fast dye, Perkin shifted his focus from synthesizing quinine to refining and commercializing his accidental invention. Perkin named the dye Mauveine after the French word mauve, referring to the purple mallow flower. With the help of his brother, Thomas, and friend Arthur Church, he developed a scalable process for producing Mauveine using coal tar as the primary raw material. By the end of 1856, Perkin had secured a patent for his dye and established a factory in Greensford Green, launching the world's first synthetic dye manufacturing operation. Mauveine's discovery was a pivotal moment in chemistry. It demonstrated the practical potential of organic synthesis and introduced the concept of using coal tar derivatives for other industrial chemicals. Perkin's work shifted perceptions of coal tar from a waste product to a valuable resource, creating a path for the development of synthetic dyes, pharmaceuticals, and materials. The success of Mauveine inspired chemists across Europe to explore the potential for synthetic compounds and marked the beginning of the chemical industry expansion, with Germany eventually emerging as the leader in synthetic dye production. Perkin's methods became a model for combining scientific research and industrial application, bridging the gap between the laboratory and real-world innovations. It was a catalyst for growth in organic chemistry, spurring industrialization, and inspired countless scientific advancements, shaping modern chemistry. Perkin's accidental success reminds us that some of the great discoveries arise not from achieving our intended goal, but from embracing the unexpected find.